Now let's go into triangles. Triangles on the SAT comes as right triangles most of the time. Let's go over some important info for the SAT before we go on. Of course, we know that the first page we mentioned that the sum of every single angle inside a triangle is 180. Other two things that are very important, equilateral triangles, all equal sides, therefore all equal angles. So each angle equals 60 degrees. All right. Isosceles, two equal sides, therefore two equal angles. So if it's an isosceles right triangle, then we get a 45 degrees here, 45, and a 90. Okay, and this side equals this side. There are two main things to know about right triangles. One is the Pythagorean Theorem. Two, Soh Cah Toa, the relationship between the sides and the angles, sine, cosine, and tangent. So let's go ahead and start with the Pythagorean Theorem. The Pythagorean Theorem was made by Pythagoras. He was a Greek guy from long ago who was very into triangles. So one day, he decided to drink a lot of coffee, got very, very excited, and realized that the sides, the two smallest sides of a right triangle, could relate to the hypotenuse, which is the longest side of a right triangle. And he came up with this formula that the hypotenuse squared, in this case c squared, is equal to the two other sides squared, to the two sum of the other sides squared. So a squared plus b squared. So that's pretty much everything on Pythagorean theorem. If you have a missing leg in a right triangle, you can use the Pythagorean theorem. If you have a missing hypotenuse, you can use the Pythagorean theorem. So pretty much that's it. So let's do it here. So the thing with right triangles is always to know which one is the hypotenuse, which one's the longest leg. So we know that the right angle is always opposite to the hypotenuse, which is very, very good for you to know. Then we can see where the hypotenuse is. We can locate the hypotenuse. So this is the hypotenuse. So this is C, this is A, this is B. So we know that A squared plus B squared equals C squared. We know that 17 squared plus B squared equals 19 squared. So we know that b squared equals, subtracting 17 squared from both sides, 19 squared minus 17 squared. Let's do this calculation in the calculator. 19 squared minus 17 squared. And this, again, let me make it clear using the rules of exponents. 19 squared minus 17 squared. It's not 2 squared. We cannot do this ever. 19 squared minus 17 squared equals 72, not 4, which is 2 squared. Okay, so be careful the assuming things and not checking things. So b squared equals 72. So taking the square root of both sides, we know that b equals the square root of 72. That's good enough for me. Let's do it here. So we got the right angle here. So we know that the hypotenuse is the opposite side to the right angle. So this is C, this is A, this is B. So we know that 13 squared plus 5 squared equals C squared. Let's do in the calculator 13 squared plus 5 squared. That's 194 equals C squared. So C equals the square root of 194. Actually, let's do some interesting stuff. Let's simplify the radical. How can we simplify the radical? I know it's a square root, so I need to find the biggest perfect square that's a factor of 72. If I don't, it's just going to take me more time to simplify it. So I know the 72 is, I know the perfect squares are 4, I know 9, 16, 36, 64, and so on. And I can see very easily here that 36 times 2 equals 72. So the square root of 36 times the square root of 2 equals square root of 72. So I can simplify the square root of 36 is 6. So square root of 72 is the same thing as 6 square root of 2. Let's try to do the square root of 194. So square root of 194, let's break it down. I know that 194, it's not a factor of 4. Let's see if it's a factor of 16. I know it's not a factor of 9 as well. So 194 divided by 16. And no, 194. Let's see if it's a factor of 36. No. Let's see, not a factor of 64. Doesn't make sense. So yeah, I think 194 is in its most simplified state. So let's not mess with this. Oops. I don't know what's going on. There it is. All right. Now let's go into Soh Cah Toa. Now that we've looked at the relationship between all the sides of a right triangle, now we're going to make it a little bit more complex. We're going to see the relationship between the angles and the sides of a right triangle. Pythagoras was not happy with only his first accomplishment, so he wanted to do more. He wanted to be better. So then he discovered the sine, the cosine, and the tangent relationships, they are, first of all, they are mathematical relationships. So sine of an angle is just some random number. Not random because it's calculated, but it's just some number. For example, let's see, the sine of 60, for example, is 0.866. It's just a mathematical relationship, okay? So sine, cosine, and tangent are mathematical relationships. You don't need to know that deep, but it literally allows us to relate the angles and the sides of a right triangle. Be sure when you're using Soh Cah Toa in the test, if needed, to have your calculator in degrees. Okay, not radians. So if you know Soh Cah Toa, you're gonna be fine. Promise you. If you know Soh Cah Toa, at every single question, write it down, so it's gonna be easier for you to remember the relationships. So we know that the sine of an angle is equal to the opposite side of that angle divided by the hypotenuse. The hypotenuse never changes, but the sides, the opposite and the adjacent sides, depend on the angle that you are analyzing. So let's see here. Cosine of an angle is equal to the adjacent side of that angle divided by the hypotenuse, which never changes, and the tangent of an angle equals to the opposite side of that angle divided by the adjacent side of that angle. Tip 5 here, the relationship you choose will depend on the angle you are analyzing. I said that before, but it's very important for you to know, therefore I just repeated it. The hypotenuse will always be the same, okay, we know that. Opposite and adjacent sides depend on the angle being analyzed. So that's the same thing as this. I don't know why I did this, but still, it's so important that I needed to write it twice. So yeah, all relationships relate one angle to two sides. Having any two values will allow us to find the missing third. For example, if we have one angle in one side, we can find the other side. If we have two sides, we can find the angle, and so on. So let's do this here. Let's see this triangle, this right triangle. We have the red angle, we have the blue angle, and we have sides A, B, and C. So let's do the cosine of the red angle. So first of all, we write Soh Cah Toa. It's already here, so I'm not going to write it. So we know that the cosine of the right angle equals to the adjacent side divided by the hypotenuse. What's the adjacent side of the right angle? It's the side that's closest to the angle. Remember, this side, which is the opposite of the right angle, is always the hypotenuse. So between A and B, we can see that B is the adjacent side of the right angle, and A is the opposite side of the right angle. So now let's check the blue side, the blue angle, sorry. So A is the adjacent side of the blue angle. So that's the adjacent side of the blue angle. And as you can see, B is the opposite side of the blue angle. Now that we've labeled it, it's pretty easy for us to fill out the tables for cosine and sine and tangent here. Not that tangent, I wrote down tangent, but we can do it. So the cosine of the right angle is opposite over, actually, is adjacent over hypotenuse. So what's the adjacent? That's B, divided by the hypotenuse, which is C. What's the sine of the right angle? So the sine of the right angle is the opposite over hypotenuse. So what's the opposite? That's A over hypotenuse, which is C. All right. What's the sine of the blue angle? The sine of the blue angle is the opposite side over the hypotenuse. So it's B over C. All right. And the cosine of the blue angle is the adjacent over the hypotenuse. So what's the adjacent side of the blue angle? It's A. A divided by the hypotenuse, which is C. As you can see, the cosine of the right angle is equal to the sine of the blue. All right, and the sine of the red is equal to the cosine of the blue and vice versa. So this is a very cool thing to notice. Let's do right here, tangent of the right angle. So the tangent of the right angle is opposites over adjacent, TOA. So that's TOA. So that's opposites over adjacent, which is, what's the opposite of the right angle? That's A divided by the adjacent, which is B. Now let's do the tangent of the blue angle, which is also opposite over hypotenuse, opposite of adjacent, sorry. But for this angle right here, which is the blue angle. So the opposite is B, and the adjacent is A. As you can see, the fraction is flipped, is reciprocal. All right, so that's pretty simple. Every single question you're dealing with Soh Cah Toa, write down Soh Cah Toa and understand the relationships, and you should be good. All right. One other thing, just knowing that each angle has their specific opposite and adjacent sides, it's very good for you to understand as well. Tip 4. Notice the two angles of a right triangle combined are 90 degrees. All right. The two, in this one, in this example, the blue and the red combined are 90 degrees. Why? Because we have already a 90-degree angle here. So what's left is 90. So we have that the red plus the blue equals 90 degrees. So that's a good thing to notice as well. Let's see step by step how we can approach a Soh Cah Toa kind of problem. First of all, we're always going to have an angle, a right triangle first, and then we're always going to have an angle that we're going to analyze, and we're going to choose between two sides. Which ones are the ones that we need, or which ones are the ones that we want? Okay, which ones are given, and then we can decide which property to use. If we're using sine, cosine, or the tangent properties. Step by step. First, what's given? Second, what do I need to find? Third, which relationship can I use that will allow me to find the missing piece? Adjacent or opposite sides are based on the angle. I cannot stress this enough. So let's do some examples here. We have this angle. So the angle is the basis of everything because the sides are opposite, adjacent, based on the angle. So now we can use Soh Cah Toa. We gotta write down Soh Cah Toa. It's gonna be easier for us. Soh Cah Toa. All right. The angle is 62. All right. So based on this angle, what are the sides of the right triangle? We know that 5.3 is the opposite because it's opposite to the angle. And x is the adjacent. Therefore, we know we need to use tangent because we're dealing with the opposite and the adjacent sides. So tangent of the angle, which is 62, equals opposite over adjacent. So the tangent of 62 equals 5.3 divided by x. So we know that we can multiply both sides by x and divide both sides by the tangent of 62. Do some little cross multiplication really quickly. So if you don't know how to do cross multiplication, it's pretty much getting two terms that if everything is being multiplied or divided, which everything is, we can get two terms and we can flip them very easily. So this would be equal to x equals 5.3 divided by the tangent of 62. Okay. So if you want step by step, what I did was pretty much I multiplied x on both sides. X tangent of 62 equals 5.3. And then I divided both sides by the tangent of 62. So x equals 5.3 divided by the tangent of 62. Get the same thing, okay? And using the calculator, remember, always degrees. I don't think the SAT will make you calculate 5.3 divided by the tangent of 62. That may be one of the answer choices, but just in case, 5.3 divided by the tangent of 62 is equal to 2.81. So that's equal to 2.81. That's what x is. All right, let's do 2. What do we have here? We have the angle 42, and we have two sides. We know that the x is the side opposite to the 90-degree angle, so that's the hypotenuse. What about the 15? The 15 is the side closest to the angle, so that's the adjacent side. So with adjacent and hypotenuse, we know we use cosine. So the cosine of the angle 42 equals adjacent side, which is 15, over the hypotenuse, which is x. So we can do the same thing for this question. We can do the cross multiplication. X equals 15 divided by the cosine of 42. Like setting up the relationship is the hardest part. After that, it's just doing some manipulation, which we already learned. Okay, so that would be a very good answer. So 15 divided by cosine of 42 equals 20.2 in case you were wondering. All right, now we do have an angle that we don't know, and we do have two sides. So we gotta know the relationship of the angle to the sides, of course, based on this angle. So this is the adjacent side of that angle, and this is the right angle. So the side opposite to that is the hypotenuse. So using adjacent in hypotenuse, we know we gotta use Ka, so cosine. So cosine of the angle equals to the adjacent side, which is 9, over the hypotenuse, which is 20. So how can we find the angle now? We got to get rid of the cosine somehow, right? So to get rid of the cosine, just like how we get rid of anything else, we got to do the opposite calculation, the opposite mathematical expression for cosine is inverse cosine. It's that easy. The inverse for multiplication is division. The inverse for addition is subtraction. The inverse for any trigonometry relationship, sine, cosine, and tangent is always sine inverse, cosine inverse, or tangent inverse. And it's in the calculator. So in the calculator, if you just press second and cosine, you're going to be able to see the cosine inverse in your screen. So the angle equals to the cosine of -1, which is cosine inverse of 9 divided by 20. So that would be a good answer choice on the test, but let's do it here. Cosine inverse of 9 divided by 20 is 63.3, just in case you need to check. All right, let's do 4. What do we have here? We also have an angle. We have the opposite side to that angle because that's the hypotenuse. So we're not using the hypotenuse, we have the opposite side, and we have the adjacent side. So we're using tangent. So tangent of the angle equals TOA, so opposite. So let me write it down here. Opposite over adjacent, so equals to 15 divided by 7. So again, we got to get rid of the tangent to solve for the angle. So we do the inverse tangent on the other side. Tangent inverse of 15 divided by 7. And this is good enough. Let's check what it is in the calculator just in case you want to check it. 65, 64.98. 65 is good enough. All right. So let's do some practice. Questions from the test. Tip 6, it's a very good tip. When you deal with right triangles, always look at the first page and see if you're dealing with any special right triangles, which are the 45, 45, 90, and the 30, 60, 90 right triangles. This is going to make your life much easier, trust me. Let's do one here. In the figure below, the sine of 90 minus x equals 12 divided by 13. What's the value of sine of x? All right. What do we know here? We know that the sine of 90 minus x is 12 over 13. But what the heck is 90 minus x? Remember how I mentioned up here that the sum of the two known 90-degree angles on a right triangle is 90 degrees? Okay, so for example, if the right angle was 60, do you agree with me that the blue angle would be 90 minus 60, which would be equal to 30? Just think about that. Okay, so coming down here, if this is x, then of course the other angle is going to be 90 minus x. That's a very important thing for you to know because the SAT a lot of times is going to throw this kind of nomenclature at you. This kind of understanding that you can have will allow you to be above the average. So this is the angle 90 minus x. Do we know what 90 minus x is? No. Do we care? No. So let's see it. So the sine of 90 minus x, so the sine of this angle is 12 divided by 13, which is, according to Soh Cah Toa, always writing down in case I need to look at it, the sine of 90 minus x is equal to the opposite side divided by the hypotenuse. So this is the opposite, and this is the hypotenuse. So the hypotenuse is this one, which is the opposite to the 90-degree angle. That's 13, and opposite is 12. So this is 12. So they want the sine of x. We know that the sine of x equals to the opposite side of x divided by the hypotenuse. Okay, so we know the opposite side of x is this one. The hypotenuse doesn't change, so this is the hypotenuse. So we know it's going to be something, right? The opposite side divided by 13. We know at least that. So A can be right, B can be right, She couldn't be right because it's divided by 12, which doesn't make sense. So no. And D is also divided by 12, so that doesn't make sense. So let's see between A and B. A is 12 divided by 13, but we know that the 12 is not the opposite. 12 is the adjacent side of X. So this also doesn't make sense. And that leaves us with B without doing a single calculation. But if you didn't pick that up at first, you could always use the Pythagorean theorem to find the missing side, because we know that this could be A, this could be B, and this could be C. So we know that A squared plus B squared equals C squared. So what is A? A is 12, 12 squared plus B squared, we don't know what B is, we're trying to find it, equals 13 squared. So we know that B squared equals 13 squared minus 12 squared, subtracting 12 squared on both sides. So B squared equals, using the calculator, 13 squared minus 12 squared. That's 25. So B equals square root of 25, which is 5. Taking the square root of both sides. So we can see that the opposite side was going to be 5. And this divided by 13 will be the answer. All right. Let's do number 2. In the right triangle above, x equals 60. So this equals 60. If this equals 60, then we know that this equals 30. And we know that this is a special right triangle right from the beginning, which is this one right here. Let's take a screenshot and paste it down here. All right. So if this is 60, so we know that 4 is the same thing as x here, so that's 4. What's the length of side AB? So AB is this one, it's 2 times x. Since we know that x is 4, then 2 times 4 equals 8. B is right. See, saved us a lot of hard thinking. Think smart, not hard. In triangle ABC, angle C is a right angle. Okay, so let's see it here. Triangle ABC. We know that angle C is a right angle, so this is the right angle. A, B, doesn't matter where A and B are, you decide it by yourself. We know that sine of A equals 0.70. And the sine of A, we know that that's equal to, using Soh Cah Toa, the opposite side over the hypotenuse. So we know that the sine of A equals the opposite, which is CB, right? So CB divided by the hypotenuse, which is AB. They're asking for the cosine of B. So cosine of B, which is this, equals the adjacent side divided by the hypotenuse. What's the adjacent side of B? It's CB. What's the hypotenuse? AB. So as we well know, the sine of one angle is equal to the cosine of the other angle. So the cosine of B also equals 0.7, since the sine of A equals 0.7, and the relationship between both of them is the same. All right. And this is it for geometry. That's pretty much all you need to know. Of course, you still got to practice. So let me know if you have any questions. I'll see you the next video.